Hello, I'm Jian, an application chemist from Shimadzu Center for Application Solutions. In this video, I will demonstrate how to use the ISR-2600 Plus integrating sphere.
Firstly, what is the purpose of an integrating sphere? In the standard direct transmission configuration, the light focuses on the light-sensitive surface of the detector. However, when a sample is placed, the difference in the refractive indexes of the air and sample causes the focal point to shift away, thus some of the transmitted light is undetected. With an integrating sphere, all of the transmitted light can be captured and detected. There are several ways light interacts with a sample. It can pass through the sample at the same direction it travels towards it, causing direct transmitted light. It can also pass through in a different direction due to refraction and scattering, causing diffuse transmitted light. The sum of both types of transmitted light is known as total transmitted light. Light can also reflect from the surface of a sample. If the angle of reflection is equal to the angle of incidence, it causes specular reflected light. Otherwise, it causes diffuse reflected light. The sum of both types of reflected light is known as total reflected light. To understand how to use the ISR-2600 Plus integrating sphere, we have to first understand its optical system. There are two light beams, the sample light beam which enters the sphere perpendicular to the sample reflectance window, and the reference light beam which enters at an incident angle of 8 degrees. Both light beams are detected by the detector at the center of the sphere. This video will demonstrate the following 4 measurement modes with the ISR-2600 Plus integrating sphere: total transmission, diffuse transmission, diffuse reflection, and finally total reflection. Let's start with total transmission. Before any measurement, place the standard white plates at both the sample and reference reflectance measurement windows. Then run a baseline correction. This applies for all measurement modes. For total transmission measurement, place the sample at the sample light entrance window using the appropriate sample holder, then start the measurement. Next, let's look at diffuse transmission measurement. After baseline correction, place the sample at the sample light entrance window. Unlike the previous measurement, remove the standard white plate at the sample reflectance window to eliminate direct transmitted light, then start the measurement. The third measurement mode is for diffuse reflection. After baseline correction, replace the standard white plate at the sample reflectance window with your sample. Any specular reflected light will be removed from the sample light entrance window, leaving behind diffuse reflected light in the sphere. Finally, we have the total reflection measurement. After baseline correction, replace the standard white plate at the reference reflectance window with your sample. The incident angle of 8 degrees causes the specular reflected light to bounce around the inner walls of the sphere, ensuring that it is detected. Thank you for watching this video.
Excellence in science. Shimadzu.